The earthquake hit San Ramon, California at 11:47 p.m. on December 19th, 2025. Magnitude 4.0. Nothing catastrophic, just enough to rattle dishes and send a few picture frames crashing to hardwood floors. The earthquake wasn't the first event that night. It was the second. What made Dr. Trent Jackson's phone ring at 2 a.m. wasn't the earthquake itself. It was what happened 6 hours before. He sat up in bed, squinting at the message from his research partner. Check the Schumann data from yesterday. Mode 4 spike, 25 hertz. You need to see this. Trent had been monitoring Earth's electromagnetic field for 17 years. He knew its rhythms like he knew his own heartbeat. The planet hums at specific frequencies, a natural oscillation between the surface and ionosphere that pulses constantly, generated by thousands of lightning strikes happening every moment across the globe. Scientists call it the Schumann resonance, and it's remarkably stable, except when it isn't. He pulled up the data on his laptop, still half asleep, expecting some solar flare artifact or instrument malfunction. What he saw made him forget about sleep entirely. At 5:23 p.m. on December 19th, Mode 4 of the Schumann resonance had spiked dramatically, 25 cycles per second, narrow as a laser, intense enough that 3 separate monitoring stations had flagged it as anomalous. The spike lasted 47 minutes, holding its frequency with a stability Trent normally only saw in controlled laboratory conditions. Then it vanished as suddenly as it appeared. 6 hours later, the ground started shaking. Trent stared at the timestamp, signal first, earthquake second. That sequence violated everything he understood about how the planet worked. Then he noticed the note his partner had attached. 3I Atlas was at closest approach, 1.8 AU. Check the ephemeris. Trent stared at the note longer than he should have. He already knew what the timing was going to show. His jaw dropped as he pulled up the trajectory data. The interstellar comet, designated as 3I Atlas, a visitor from another star system, had reached its closest point to Earth at exactly 5:17 p.m. on December 19th, 6 minutes before the electromagnetic spike, 6 hours before California's fault system, silent since 1861, suddenly decided to wake up. You're probably thinking this is coincidence. Trent thought so too at first. He spent the next 3 days trying to prove himself wrong, running statistical analysis, checking for data corruption, looking for any mundane explanation that would make the timing less terrifying. The numbers didn't cooperate. Here's what we know about 3I Atlas. It's the third confirmed interstellar object humans have ever detected, discovered in July 2025 by telescopes in Hawaii, roughly 2 kilometers across, composed mostly of ice and rock, traveling at 110,000 miles per hour on a trajectory that proved it came from outside our solar system. NASA tracked it carefully, announced it posed 0 collision risk, and the public mostly ignored it because space rocks pass by Earth constantly. At closest approach, Atlas was 170 million miles away. You could fit the distance between Earth and Mars into that gap. safe by every metric that matters for impact scenarios. But nobody was measuring electromagnetic interactions. The northern Calaveras Fault runs through the hills east of San Francisco Bay. It's part of the San Andreas system, capable of generating magnitude 7 earthquakes when enough tectonic stress accumulates. For the past 164 years, it had been accumulating in silence, locked by friction, storing energy like a compressed spring. On December 19th, it released that energy in a cascade of tremors that seismologists are still arguing about. Dr. Charles Biggs, who has studied California's fault systems for 23 years, described the pattern as deeply wrong. Not the magnitude, the sequence. Earthquake swarms typically build gradually over days or weeks. This one erupted in concentrated bursts, releasing energy that should have taken months to accumulate. The main shock hit at 11:47 p.m., but smaller tremors continued for 6 hours, clustered so tightly that seismographs recorded them as nearly continuous vibration. In several Bay Area homes, motion sensors triggered repeatedly for hours, logging movement even when no one was there. It looked, Biggs told me during our phone interview, like something flipped a switch. Trent sent his preliminary analysis to colleagues in December. Most dismissed it as correlation without causation, the kind of pattern humans are neurologically wired to find even in random noise. A few responded with interest, but skepticism. One geophysicist in Tokyo asked a question that made Trent's stomach drop. "Have you checked whether this has happened before?" He hadn't. He spent the next 2 months digging through historical Schumann resonance data, looking for similar Mode 4 spikes. He found 3. November 2019, narrowband spike, silence. Then the ground moved, magnitude 5.2 earthquake in Albania 7 hours later. March 2021, narrowband spike, silence. Then the ground moved, magnitude 6.0 earthquake in Greece 5 hours later. September 2023, narrowband spike, silence. Then the ground moved, magnitude 4.8 earthquake in Morocco 8 hours later. None of these events were connected to interstellar objects, but the pattern held. Narrow frequency spike, then seismic activity, always in that order, always within 12 hours. The question isn't whether electromagnetic signals can trigger earthquakes. The question is what's generating the signals precise enough to do that. Earthquake triggering is real and documented. Tidal forces from the moon can nudge critically stressed faults toward failure. Distant earthquakes send waves through the crust that disturb other faults thousands of miles away. Even atmospheric pressure changes can add tiny amounts of stress that push a fault over the edge when it's already close to breaking. But electromagnetic triggering is different. It's controversial because the mechanism isn't obvious. How does a frequency in Earth's background electromagnetic hum translate into enough physical force to unlock rock that's been stuck for 160 years? The answer might lie in something called piezoelectricity, quartz, which saturates fault zones throughout California, generates electrical current when mechanically stressed. The reverse is also true. Apply the right electrical field to quartz-rich rock, and you don't just stress it, you coax it. At large scales, with the right resonance, that microscopic stress might be enough. Dr. Tony Tanaka, a geophysicist at Tokyo University who specializes in electromagnetic precursors to earthquakes, explained it to me like this. Imagine a wine glass already stressed to its limits. You don't need to hit it hard to make it shatter. You just need to sing the right note. 25 hertz is apparently the right note for the Earth's crust. The implications cascade outward from there. If narrowband electromagnetic signals can trigger seismic activity, where else might those signals come from? Solar storms are the obvious candidate, but those produce broadband chaos, not surgical precision. The December 19th spike was clean, focused, almost artificial in its purity, too clean for anything generated by weather, geology, or chance. 3I Atlas was generating X-rays as it passed through the solar wind, a known phenomenon where charged particles collide with cometary gases. Radio telescopes detected emissions across multiple frequencies, but nobody was specifically monitoring for signals at 25 hertz because nobody thought to look. Trent's analysis suggests Atlas was broadcasting electromagnetic noise across a wide spectrum as it interacted with the sun's magnetic field and particle streams. Most of that noise dissipated harmlessly into space, but some frequencies might have coupled with Earth's magnetosphere, propagating down magnetic field lines into the ionosphere, where they could excite the Schumann resonance cavity. It's plausible, barely. The energy requirements are enormous. The coupling efficiency should be terrible, and the distance makes the inverse square law brutally limiting, unless there's amplification we don't understand. One possibility Trent couldn't eliminate was that Earth itself wasn't just receiving the signal, it was reinforcing it. Here's where it gets uncomfortable. The other three historical spikes, the ones with no interstellar objects involved, suggest something on Earth is occasionally generating 25 hertz signals, powerful enough to stress fault systems. Natural process? Industrial activity? Nobody knows. The spikes appear randomly, last less than an hour, and vanish without clear cause. Finding them required months of data analysis because they're rare enough that standard monitoring protocols don't flag them as priority events. They look like minor anomalies, statistical blips, the kind of noise that happens constantly in complex systems, except they keep appearing right before earthquakes. 3I Atlas is currently 3.2 astronomical units from Earth, heading back into interstellar space at 110,000 miles per hour. It will never return. Within 5 years, it will be beyond the orbit of Uranus, cold and dark and forgotten by everyone except astronomers maintaining databases of transient objects. By the time it passes Uranus, whatever interaction it had with Earth will be long over. Its evidence preserved only in datasets no one was ever meant to connect. But it's not the last interstellar visitor we'll see. Current estimates suggest 5 to 10 objects, larger than a kilometer, pass through the inner solar system every year. We've only confirmed 3 because our detection capabilities are still catching up to reality. The Vera Rubin Observatory will change that when it begins operations later this year. Its survey telescope will scan the entire visible sky every 3 nights, identifying everything that moves or changes. Astronomers expect to catalog dozens, possibly hundreds of interstellar objects within the first few years. Each one will be tracked, each one will be studied, and now, thanks to Trent's work, each one will be monitored for electromagnetic emissions at 25 Hz. Because if the correlation is real, if these cosmic wanderers can reach across millions of miles and unlock faults that have been holding their breath for centuries, then our models of planetary risk need updating. Distance alone doesn't guarantee safety anymore. Trent published his findings in January 2026. The paper has been cited 247 times already, half of them in seismology journals, half in space physics. Review articles are appearing monthly, some supporting his analysis, others attacking his methodology with the ferocity academics reserve for ideas that threaten established understanding. Nobody can explain away the timing. The northern Calaveras Fault is quiet again. For now, it released enough accumulated stress that geologists estimate it won't produce another significant earthquake for at least 3 decades. The energy is gone, dissipated into seismic waves that rattled through the Bay Area and faded into memory. But the San Andreas itself remains locked and loaded, accumulating stress at 2 inches per year, overdue for a major rupture that could affect millions of people. Every fault in California sits in a similar state, stressed, critical, waiting for that final nudge that transforms stored energy into violent motion. And somewhere out there, between the stars, objects are drifting through the darkness. Some are ice, some are rock, some are something stranger that we haven't classified yet. They move at speeds that make our fastest spacecraft look stationary, carrying with them the electromagnetic signatures of their interactions with stellar winds and cosmic radiation. Most will pass through our solar system unnoticed and harmless, but maybe, just maybe, one will arrive at exactly the wrong moment, broadcasting exactly the wrong frequency, finding resonance with a planet whose faults are already desperate to move. The universe doesn't care about our infrastructure, or our cities, or our carefully constructed lives on tectonically active ground. It simply exists, vast and indifferent, operating according to laws we're still discovering. 3i Atlas taught us something about those laws, whether we wanted to learn it or not. The next interstellar visitor is already on its way. Statistically speaking, it always was. We live on a tiny dot in the vast, vast universe. Who's to say what else is out there and how or when we may interact? I hope you enjoyed this story. Be sure to leave a comment and subscribe to help my small channel out. I appreciate you all so much, and until the next Dark Veil tale, have a frightfully fun day.